Hello, in the last video we discussed about some of the application of the integral, right? So before that we learned some techniques of integration. For example, how do we find the integral involving inverse function, integral involving natural logarithm function, exponential function, and also we learned how do we use substitution method, right? So on this chapter, starting from 8.2, section 8.2, chapter 8, section 2, we'll learn one more new technique that is called integration by parts. In other words, it is the product rule of integration. You remember that? There is a product rule in the derivative. So similarly, we have product rule in the entire derivative as well. Okay, so first of all I will derive that formula, how that formula works, and then we will do some examples on that. Okay, all right, so what is the product rule of derivative? So do you remember that? That is f times g prime is equals to f prime times g, right? And then plus f times g prime. That is the product rule in the derivative, right? So I want to derive the formula for the entire derivative of the product. So what I'm going to do here is I am going to integrate on both sides. If you integrate, what do you get? Integrate implies integral of that will be just f times g, correct? Equals to, what do you get here? Integral of f prime times g dx, right? And then plus integral of f times g prime dx. Does that make sense? Now, so what I want to do from here is, so I can write this as like, let me write this way. So what is f times g prime integral dx? Then I'm keeping this in one side and moving that in other side. What do you get? You get f times g, okay, minus, you move that to the other side, you get integral of f prime times g dx. Okay, so in the book you could see that this is the format of the integration by parts, but what I want to do is I want to write in the actual product form. Okay, so what I want to do is, after that what I want to do is I want to do one more steps. I want to go one more steps than the book. Okay, let u equals to f, and then g equals to so g prime equals to v. Okay, so what will be g then? Then g will be just integral of that, right? Integral of v will be the g. You see that? Integral of v will be the g. Okay, so if you do that, what do you get on the left side? Then you get integral of u times v dx. You see that? U times v, because g prime is v. So I want to get the formula in terms of the product of two functions. Okay, u times v dx will be how much? You will get f. Okay, so sorry, f is u, right? So that is u times integral of v dx. You see that? U times integral, because g is integral of v dx. You see that? And then minus integral of f prime is how much? F prime is u prime, right? U prime. And then times g is what? G is integral of v dx. This is the big integral there is outside, and then that is dx. Okay, so you can write this format. You can write your formula in that format, meaning that if you have the product of two functions and if you want to find out the integral of the product, okay, then the formula is u times integral of v minus big integral, inside that big integral, derivative of u times integral of v dx. So you can use this format of the formula, okay, but book uses this format. Okay, so the book, or you may have seen integration by parts before. If you have seen that, then it uses like this format of the formula. Okay, it uses this format of the formula, but I like to use this format of the formula. Okay, so I will consider one function as u and the another function as v, and then the product of the integral of the product will be a function u times integral of v, the integral of the second function, minus big integral and the derivative of u, the derivative of that function that was left outside the integral, times integral of v dx, and there is dx outside. We'll see example. These things will be very clear. Okay, again, book use this format of the formula, but I like to use this format. This is one step forward. Okay, now, so you may be curious, usually which function should be u and which function should be v? Usually what we do is, u is a function that is easy to find the derivative. Okay, easy to find derivative. Usually almost all the function you can find the derivative, right? But when you consider v, you should be a little bit careful. Okay, so when you consider v, what you do at that time is v must be the one that is easy to integrate. Okay, that is the thing, easy to integrate. That should be easy to integrate. Okay, so v must be the function that is easy to integrate. Alright guys, so there is one rule of which one should be u and which one should be v. Okay, which one should be u and which one should be v? That formula is ILATE. Let me write down that. ILATE. Okay, so what is this ILATE means? These are for the u. Okay, to consider u, if the integral has inverse function, I stands for inverse function. Okay, if the integral has inverse function, then that must be u, the other remaining another function should be v. If there is no inverse function, and then if there is a log function, if there is inverse and then log, then I must be u, the other one must be v. Okay, and if there is a log function in the integral, then the log must be u, the other one must be v. If there is no inverse and log function, but if there is an algebraic function like x squared, x cubed, x to the fourth, like that, or x to the 1/2, like that, then that should be u, the other function should be v. Okay, if there is no inverse, no logarithm, no algebraic, but there is a trig function, then trig function must be u, the other function must be v. And finally, if there is exponential function, so these are in order. Okay, so these are in the priority. So if there is an inverse function, that must be u, that's the first priority. If there is no inverse, look, if there is a log function, if there is a log function, that must be u. Okay, and if there is no inverse and log function, but if there is an algebraic function, that must be u, and so on. Okay, so alternative method is used only if, okay, only if there is there is a certain format of the function. For example, if there is like x to the n times e to the x type of function, then one should be u and another should be v. And then for the u function is the one that you find out the derivative, right? You find out u prime, u double prime, continue finding out u triple prime, and so on, until you get 0 here. Okay, and the other one you integrate v, so integration so it is integration of v, and then whatever you find out, again find the integration, so continue finding the integral of that. Okay, on the other one, and then after you do that, you just find out this product, and the another product is the negative sign product. Okay, and another positive sign product, another negative sign product, until you hit 0. Okay, that's what we do. So when we see the example, the things will be clear. Okay, so the book is using this formula of the entire derivative, the product rule. So they will consider one is f, another is g prime. But what I'm going to do is I will use this formula. One function I will consider u, another function I will consider v, and I'll be using the integration by parts, the product rule here. Okay, product of the integral. Okay, So I'll be using this formula, but you are free to use any formula. Again, there is an alternative formula, but this method works only for a certain type of function, not for all types of product. Okay, only certain type of product. We will see that example. So let me do some examples. Finding integration by parts. Some of the integration by parts or some of the product, integral of the product can be used using the substitution method. You guys know that already, right? But you can use by using the integration by parts as well, no problem. So the first problem that I want to do is I want to do question number let's say 14. Okay, I want to do question number 14. Let me do 14. It asks you to find out x and then cosine 4x and then dx. Okay, so but the book asks you to take u equals to x and dv equals to cosine 4x dx, and then use that formula, u times dv, like that, right? But what I want to do is I want to use this formula. So I'm taking that, let's say u equals to x. Why did I choose u equals to x? And then v equals to cosine 4x. Why did I choose u equals to x? Look at that, ILATE. Is there inverse function? No. Is there logarithmic function? No. Is there algebraic function? Yes. This is algebraic function. If there is algebraic function, that must be u. Okay, I picked that as u and the other one as v. Okay, so now what is the formula? The integral of u times v is equals to, so let me write down that, so that will be equals to, so this is like u, right? This is like v. What is the formula? U and integral of v, right? So it is u is x and integral of v, so cosine 4x dx, and then minus integral derivative of u. What is the derivative of u? That is x. The derivative of x is 1, right? Times integral of cosine 4x dx, and then outside there is a dx there. Okay, so what is the integral of cosine x? Do you guys remember that formula? The formula is, let me write that formula. The formula is integral of cosine of x, cosine of, let me write cosine ax. Okay, if there is a number ax dx is what? Sine ax over a plus c. Okay, because the derivative of sine is cosine. If there is an integral of sine, then the formula will be negative cosine, because the derivative of negative cosine will be sine. Okay, so let us use that formula here. What do you get? You get x times sine 4x over 4. I will write plus c at the end, no problem, right? Minus integral of, what is the, that 1 times that is just that that thing, right? So what is the integral of cosine 4x again? It is sine 4x over 4 dx. I'll write plus c at the end. Okay, now so this outside integral is left here, right? Because inside integral we use that formula already. Now what is the formula for the integral of sine ax dx? That will be what? That will be cosine negative cosine. Okay, cosine negative cosine ax over a plus c. Actually that number that multiplying to x will be dividing. If you are finding the derivative, that will be multiplied, right? If you are finding the entire derivative, then that will be dividing. So what do I get here then? So that will be, that will be 1/4 x sine 4x, right? And then minus 1/4 is outside, then you will get sine 4x integral dx. Now I want to use the formula again. So 1/4 x sine 4x, right? And then minus 1/4. What is the integral of sine 4? It is times negative cosine 4x over 4, and I'm writing plus c because there is no more integral left, right? So the final answer is 1/4 x sine 4x minus plus 1/16, because negative times negative, right? And then cosine 4x plus c. That is the final answer. So what I'm going to do next is I'm going to show you how to use that table. Okay, so table is usually used if one of the, I cannot guarantee that all the problem works on that type, right? So the alternative method, but sometimes if one of the function is the trig function, and when you continue to find out the derivative, if the exponent of x decreases to 0, or if there is like x to the cube, x to the 4 like that, or x like that, if you find out the derivative, it will terminate, it will go to 0. In that case, this method will be easier. For example, let us use that, because this is one algebraic function and another is trig function, right? So as again, if there is algebraic and trig, which one should be u? It says the a should be u, because it is on the first priority, right? The inverse will be the first priority. If there is no inverse, log will be the first priority for u. If there is no log, algebraic should be the first priority. If there is no algebraic, then trig, but there is algebraic function. So polynomial function kind of, right? If there is a polynomial function, then that should be u, the other one should be v. So what I'm going to do here is I am writing u and then v here. So what is u? We denote u as x, right? And then v is cosine 4x. So what we do next is we try to find out the derivative of the u. So what do you get? What is the derivative of x? It is 1. What is the derivative of 1? 0. See, it terminates to 0. In that case, this method will be a lot easier. Okay, guys. Now, let's find out the antiderivative of v. What is the antiderivative of cosine 4x? It is sine 4x over 4, right? And what is the antiderivative of sine 4x over 4? It will be negative cosine 4x over 16, right? Why there is 16? Because there is 4 already. You can pull that 1/4, right, as 1/4. And the integral of sine 4x over 4 is negative cosine 4x over another 4. So there will be 4 times 4 will be 16. Since it terminated as 0, you don't need to do anything after that, and you stop here, okay? Now the next idea after you do find out derivative and antiderivative is, you write down the first arrow is positive sign, the second arrow is negative sign, like this, right? And since there is 0 after that, you stop there. Now, what is the answer then? The final answer here would be, so it is, so let me write down the question on the left. It is x times cosine of 4x dx will be, this is 4x there, right? So this is equals to x times that will be x times sine 4x over 4 is 1/4 x sine 4x, right? And this is a negative multiplication. 1 times negative, this is negative multiplication, okay? Negative times negative is positive, plus 1/4 cosine 4x, right? Because 1 times that is, 1 over 16 cosine 4x, and then don't forget to write down c at the end. You see that? This is just one line, right? Just one line to find out the answer. But this method is used only if there is a polynomial function there, so that when you find out the derivative, it will terminate to 0. Okay, it will terminate to 0. All right. So let me do another example. That is example number 17 from the book. Again, you want to find out the antiderivative. It is x cubed e to the x, integral of e to the x times x cubed dx. It doesn't matter. It is like the product of two functions, right? So which one should be u? Which one should be v? What do you think? Look at that, I-L-A-T-E. I-L-A-T-E. See, exponential function is least preference for u. Okay. Before that, trig function like that. But if usually we look this way, this direction. Okay. If there is an inverse function, that should be u. There is no inverse function. If there is a log function, that should be u. There is no log function. If there is an algebraic function or polynomial function, that should be u. Yes, this should be u. Okay. So what I'm going to do is, this is u, this is v. Okay. Now we use that formula. So integral of u times v is u and then integral of v. Okay, and again this problem is easier if you use the this tabling method or charting method. Okay, but I will show you both method, and in the exam or in the test or quiz or anything homework, you can do either method you like. Okay guys, so let us do that. So that is u, that is v. The formula says that this is equals to u is x cubed times, what is the integral of v? What is integral of e to the x? It is e to the x itself, right? Minus, so integral derivative of u is 3x squared, and integral of v is e to the x and then dx. You see that I'm using the derivative of u and integral of v inside there. Now how much is that? X to the cube times e to the x minus 3. Now again this is like x squared times e to the x. Again product of u and v, right? So again this is the algebraic function or the polynomial function, that should be u. So it is e to the x. So x cubed times e to the x minus 3. Let me write down the bracket. What is the integral? This is like u, this is like v, right? And use the formula u integral of v, that will be x squared times integral of e to the x is again e to the x, right? Minus, what do you get? The integral derivative of u is 2x times the integral of v is e to the x itself, so dx. You see that? So what do you get? You get equals to x to the cube times e to the x minus, let me distribute that, 3x squared times e to the x plus, because negative 3 times you can pull that 2 out, you get 6, right? And then integral of x times e to the x dx. Again there is again u times v, that's again integration by parts, right? U times v like that. So what do you get? You get x cubed times e to the x minus 3x squared times e to the x plus 6 times, let me use a bracket there as well. So it is a product of two functions u and v, right? So it will be u is x, integral of v is e to the x. So because integral of e to the x is e to the x minus integral derivative of u is 1, because derivative of x is 1, right? Times integral of e to the x is e to the x itself, there is dx. Okay, so what do you get there? So it is x cubed times e to the x minus 3x squared times e to the x plus, let me distribute that 6 times 6x times e to the x, right? Minus 6 times, so what is 1 times e to the x is e to the x, so integral of e to the x is e to the x itself, e to the x, and then plus c, don't forget that plus c there. Okay, so that is the final answer. It was kind of a little bit longer, right? But if you do the table method, like charting method, it will be a lot easier here. How? Because this is in the nice format. One is the polynomial function, other is different type of function. One is the polynomial function, other is different type of function. Okay guys, so again, so what you get there is, look at this, let me write down the table there. So which one should be u again? This is the priority method, so there is no inverse, there is no log, there is algebraic or polynomial function. So I am using that as u and then the other one as v. So u will be x to the cubed and v is e to the x. Okay, I want to find out the derivative. So what is the derivative of x to the cube? 3x squared. What is the derivative of 3x squared? 6x. What is the derivative of 6x? 6. What is the derivative of 6? 0. I stop here. Okay, now similarly find out the entire derivative of e to the x. It is always e to the x. Entire derivative of that is e to the x. Entire derivative of that is e to the x. It is e to the x. You see that? Now what is the integral then? So I want to just write down the arrow, right? The positive arrow. You see that? You do the arrow like little bit slanted arrow. You just skip the first one, and then the first one on the left is matched to the second one on the right. That's how the method works. Okay, and then the second on the left will be matched to the third one on the right. So this is the alternatively, that's the negative. So the first one is positive multiplication, the second is negative, third is positive, the fourth is negative, and now it is terminated because there is 0 after that, right? So what is the final answer then? The final answer is, let me write down the question on the left side, e to the x, x to the cubed dx is equals to, write down x cubed times e to the x, next is negative multiplication, minus 3x squared times e to the x, right? And then next is positive multiplication, plus 6x times e to the x, and then last one is the negative, minus 6 times e to the x, and then plus c. You see that? You will get the same answer, but it is a lot easier, right? But this table method may not be useful for all types of problem. Okay, it is useful for only this type of problem. That means one of the function in the product must be a polynomial function, meaning the derivative must go down to 0 ultimately. Okay, all right, that's all for this video. I am taking more examples in the next video. Okay guys, thank you.